Dear all, today we discuss what is concept learning and find its algorithm and the related problem. First, let us understand what is concept learning with an example. Concept learning is a machine learning approach where we try to learn a concept with the help of real instances. So the machine is able to learn the concept by referring to the real instances with the target outcomes. For example, in this case, observe here in the data set, the instances X, that is nothing but the possible days with related to the weather attributes that is described as below. That is sky with the possible value as sunny, cloudy and rainy, air temperature with values warm and cold, humidity with values normal and high, wind with values strong and weak, water like warm and cool, forecast with the same and change. Okay, when such instances are given, so we have to define the hypothesis. What is hypothesis? Hypothesis is described by a conjunction of constraints on the attributes. The constraints can be that is represented by the question mark, that is any value is acceptable, and phi, that is no value is acceptable, or a specific value. So there are three possibilities. We represents the constraints, and the target concept is represented by a Boolean valued function. So where the outcome is either yes or no. The training examples represents the positive and negative examples. So it is a collection. So we have to observe here. So once we are able to define the hypothesis, next we are about to observe what is general hypothesis, what is specific hypothesis related to the instances that is given. That is the most general hypothesis is represented by considering the number of attributes given in the instances set. That is nothing but the data set. So as per the data set, we can observe here, there are totally 6 attributes are there. So we are representing the same as 6 question marks here. That is, it represents the most general hypothesis where the question mark can represent any value. And most specific hypothesis is represented by the phi symbol where it is representing no value. That is, there are totally 6 attributes are there, and then 6 pi symbols we are using. It represents no value. So next we have to observe here what is the hypothesis, what actually we are about to understand here. The hypothesis in hypothesis set such that h of x is equal to c of x for all x in x. Nothing but, so we are going to find a hypothesis which best fits all the training examples in the given instances. That is, training examples are nothing but what? The examples given in the instance set. We can observe here the instances for which C of x is equal to 1 are called positive examples, are the members of the target concept. Instances for which C of x is equal to 0 are called negative examples, are non-members of the target concept. So you can relate here any hypothesis found to approximate the target function well over a sufficiently large set of training examples will also approximate the target function well over other unobserved examples. So this is the way machine is going to learn about the concept, and it is used for decision making. Next, we realize concept learning as a search. The goal of this search is to find the hypothesis that best fits the training examples. So this we have already discussed the sample data set. So next, related to this, so we are going to understand an algorithm that is a find yes algorithm. The goal of this algorithm is to find a maximally specific hypothesis. So what are the steps involved this algorithm? Initialize the hypothesis to the most specific hypothesis in H, that is the hypothesis set, for each positive training instances in instance X, for each attribute constraint, that is the single attribute, any attribute we consider in the training set in H, if the constraint A, that is nothing but the attribute A, is satisfied by the instance, then do nothing. Else, the replace the attribute in hypothesis by the next more general constraint that is satisfied by X. Once it is done, so next we are going to output the hypothesis H. So for example, if the data sets consists of n number of training instances, so in that we have to only focus on positive training instance. The finders algorithm only focus on positive training instance and it will neglect the negative training instance. And when there is a positive training instance, so it is going to observe that for each attribute constraint, if the constraint A, that is the attribute value, is satisfied by the instance, then we are not going to take any action. Otherwise, we are going to replace that attribute value in the hypothesis by the next more general constraint that is satisfied by X. Once it is done, finally, we consider all the attributes, then we output the hypothesis H. So next we will see an example related to this. Candidate elimination algorithm with finders techniques, that is the problems. So we will observe one by one what are the different approaches are there. That is, one is the candidate elimination algorithm, another one is the finders approach. First we understand about the finders learning technique, afterwards we discuss about the candidate elimination approach. So for the given data set, find the maximally specific hypothesis using the finders technique. So here the data set is related to the book buying, that is, it represents the book attributes and the target is buy or not buy the book. So now we can relate here. So the attributes include citations, size, in library, price, editions, and then buy. And in that, the attributes values are like this, that is some, many, related to the citations, and the size comprises of that is small, big and medium attribute values. In library, no and then always values. For price it is affordable and then expensive. For edition it has value one, many and then few, and the target is that is by whether buy the book, to buy a book or not, that is yes or no. So first what we supposed to do in order to find the maximally specific hypothesis. So first, before that, we try to answer few questions related to the how actually we use the finders technique and also the candidate elimination approach, such that how we are able to observe the given instances and then its related outcome, and then how actually we are able to identify a hypothesis. First, we go through this question. Explore the instance space related to this data set and find out how many concepts are possible for this instance space. So now we have to observe here. Consider every attribute values and find out the distinct values except the target. For example, we let us take the citations. It has two distinct values. So we can say some and many. And then similarly, go to the size and we have small, big, and then medium. That is three distinct values. And in library, again, two distinct values are there. And then price, it has two distinctive values, that is affordable and then expensive. Then editions, it has three distinctive values, many, one, and then few. So many, one, and then few. And we can observe here, so we have to leave the target concept and then we are going to find the total concepts by multiplying the distinct values related to each attributes. That is 2 into 3 into 2 into and again 2 into 3. So altogether there are totally 72 concepts that can be related to the what that is possible with this instance space. So the second question, let us understand how many hypotheses in the hypothesis space that is related to the training examples. So we can observe here, so the most specific is represented by the phi symbol and the most generic is represented by the question mark. So that is, we can say that there is a most specific hypothesis as well as most generic hypothesis. So these two will be common, and these we are going to add to every possibilities for each attribute. So we know that for citations, there are two distinct values are there. So for that, we are adding these two, that is the number of hypotheses. So now altogether it is 4. Similarly for size, so we can relate size, it is 3 and then 3 plus 2, 5. And then in library, there are two distinct attributes, 2 plus 2, 4. And again price, 2 plus 2, then 4. And then additions, similarly 3 attributes, values, that is 3 plus 2, 5. So altogether, it is 1600 hypotheses are expressed by the hypothesis language. So it indicates that these are the hypotheses are possible. So we have to find out the maximally specific hypothesis which best fit all the training examples. Next is semantically distinct hypothesis. So in order to find out this, what we have to do, we have to exclude the null hypothesis and add question mark to the every possibilities for each attribute. So there are two hypotheses, that is generic and then specific will be there. So we'll be removing the most specific and we are considering only the generic one, and we are adding to the every attribute possibility. So we can observe here for citations, it is, we can observe here for citations, it is two distinct values. So we are adding 2 plus 1 as 3, size 3 plus 1 as 4, in library 2 plus 1 as 3, price 2 plus 1 is equal to 3, and additions 3 plus 1 is equal to 4. So altogether 433 semantically distinct hypotheses. So next we understand using the FIND-S algorithm how to find the maximally specific hypothesis. First we have to initialize, that is the most specific hypothesis, like this. Next, what we supposed to do, so we have to observe that in the given training data set, positive example or the negative example is there. So now we can observe here in the training data set. So in the first example, so we observed the negative training example. So if the outcome is negative, so the FIND-S algorithm going to neglect this. So we are not going to alter anything. So we are retaining as it is. So next we encounter the positive example. So we can observe here the outcome is yes. So then we are replacing all the 5 symbols with the attribute value, whatever we are observed here. That is many, big, no, expensive, one. The same we are going to write it here. Many, big, no, expensive, one. So next what we are going to do, so next we go with the what? The training example. So we can observe here. So again, the third training example is negative. So we are retaining whatever we have observed in the previous iteration. So we are going to retain as it is. So we can observe here many, big, no, expensive, one retained as it is. And again in the fourth training example, so we can observe here. So the outcome is positive. So now what we have to do, we have to do the comparison. So we can see here that is many, medium, and no is there. So let us take the comparison. Many is matched, many is matched, and then we can see here there is big, and in the data set we have medium. So now we are replacing this by the question mark so that it can represent both the target attributes, sorry, the attribute values, that is big and then medium. And then no is there as it is, we have retained, expensive we have retained, and then we can observe here the last attribute value, that is here we have many, and then whatever we have written in the hypothesis as one. So now this is replaced by the question mark. So we can observe here. So now finally, again what we are going to do, so we are encountering one more positive example, that is many, small, no, affordable, and then many. So now we can observe here, we are comparing all these attribute values, and then we can observe here, so the many, question mark, no, that is represented by all, and the expensive is replaced by question mark. So we can go here So in this case, so we have observed the expensive we have written. So now here it is affordable. To make it general, so what we are going to do, so we are replacing this by the question mark, and then we have replaced already this one as a question mark. So we can see here it is already replaced as question mark, since question mark represent any attribute value. So this will be the what, the most maximum, you can say that the generic hypothesis means the maximally specific hypothesis which best fits the all the training examples. So now in this case, so we have 1, 2, 3, 4, 5 training examples. So that hypothesis which best fit all the training examples.